Now, this is not going to be a full lecture on squeeze theorem, just a little quick review of the application of squeeze theorem. So say you want to take some limit. Say I want to evaluate this limit. And unfortunately, f is a difficult function to work with, but I'm able to create an inequality like this with a g of x down here and an h of x up here. And this just has to be true for an open interval, just some interval, containing x equals c. So it doesn't have to be for all values of x, just for an interval containing this x equals c. And let's say you can also show the limit as x approaches c of this g of x is some finite number. And it just so happens the limit as x goes to c of h of x, the generally larger function, is also that same. These are the same. These both come out to the same finite number. And you could show the equal here, or just have a 2 and a 2 there, a 3 and a 3, or a 1 and a 1, whatever. Well, if you ever can show this and this, both of these are true, you have enough to say triple dot by squeeze theorem, comma, this limit is also that finite number. A very quick example. And in this case, the c is not even going to be a real number. The c is going to be an infinity. Very common example. What if I wanted to take, leaving myself a strategic gap here, what if I wanted to take the limit as x goes to infinity of cosine x over x? Could just as easily be sine x over x. Well, cosine x is always greater than or equal to -1 and always less than or equal to 1. You can graph cosine and see that. And obviously, if I only consider x's that are greater than 1, let's just worry about x's greater than 1. Pull this over just a little bit. If we only consider x's greater than 1, you probably could accept this as well. And go ahead, graph this, graph this, graph this in red, green, and blue and Desmos or something, and just look at x is greater than 1, and this inequality will be true. And if you took the limit as x goes to infinity of -1 over x, -1 over infinity would be 0. If you took the limit as x goes to infinity of 1 over x, that would also be 0. So you'd have enough to say triple dot by squeeze theorem, comma, this would also have to be 0, because again, these are equal. Came out to a finite number, so too would this one have to be equal to 0 by squeeze theorem. Hopefully you found that helpful.